In this presentation, I'm going to show you the process for designing the frame. So one thing to think about is try to make something unique and fun, and it's actually going to be functional for you. I strongly recommend you pay attention and follow the process that I outline here. What happens is if you don't, you may end up creating a bunch of extra work for yourself. First step would be research existing designs of frames. So you don't need to reinvent the wheel. But be careful about falling in love with one particular design. I'll talk about some specifics here in a minute. But look at aesthetics. What does it look like? Remember, we're looking for clean lines, smooth bend frame. The size of the frame is important. Think about the function. What we're doing is not an off-road vehicle. It's also not a racing go-kart. So look at overall size, complexity of the frame. Don't make it too complicated. Performance criteria like the weight, size, of course, the size of the engine, and then the tire sizes are going to come into play. So here's just some examples of some different types of go-kart frames. Now, you'll notice I've got a variety. Some of these are racing type frames, and some are more like considered fun karts. So it's a good idea just to look around and see what's available to get the feel for what you want your frame to look like. So pay attention to frame geometry. There's really, let's eliminate like off-road kinds of karts because that's not what we're building. Ours would be for like hard surface, a street, parking lot, that kind of thing. So in that category, we're going to have two kinds, and that would be a racing go-kart and a fun kart. Now, racing go-karts, as the name implies, they're really designed for racing. Now, certainly you could build a racing go-kart and drive it on a parking lot. The real difference is with racing go-karts, they want them very low to the ground for better handling and so that they don't flip over. In order to accomplish that, what they do is they have a very flat frame, and you'll notice that the rear axle is mounted above the frame, and that lowers the back end. So you see you only end up with just a couple of inches of clearance between the frame and the road that you're driving on. Now, our kart is not going to be for a racetrack. We're going to be driving it on a parking lot, which is going to have irregularities and dips in the surface and those kinds of things. And you want to be able to like go over a grade without the frame catching on that. So we want to design a frame that is not flat. And what that will let you do is it'll let you put the rear axle underneath the frame. If you don't accommodate for that, if you put the rear axle under the frame and your frame is flat, then the vehicle is not going to sit level. So we want to try to make it sit as level as possible. Here's a couple of examples of some frames that, these are very similar, but you can see what I'm talking about in terms of how the axle is mounted below the frame. Another thing to think about, and this is going to affect the front end of your frame design because this is for drifting. Now, drifting is an interesting motorsport and where people slide their cars around a track, and it's in a very controlled manner. It's not just about doing donuts. In order to control a vehicle when it starts sliding, you want to have the ability to turn your front wheels a lot more than a standard vehicle, and that'll allow you to keep from spinning the vehicle out. So like on a car, what they do is put something called an angle kit. And here's some pictures of cars that have angle kits, and look at how far this front wheels are turned. It's much more than your average vehicle will turn. That would give you a very sharp turning radius. So we want to do something like that with our kart. So with standard go-karts, the front wheels turn maybe about 30 degrees from vertical, from forward, I should say. We'll probably try to have twice as much as that. So you want the front wheels to be turn a lot. In order to do that, you have to keep the frame narrower in the front. The rear of the frame should still be a little bit wider in order for to maintain stability of the vehicle, and also so you have enough room for the seat and the engine and everything. So we will want to taper the frame in the front so it's narrower. That will allow space for the tires when you turn them sharply. Think about the overall size of the vehicle. I think in the first handout I said maximum length 55. I've kind of reconsidered that. So somewhere between 55 inches and 60. And that's the total overall length. So keep it under 60 inches. If not, you're going to have to redesign it. The width is also very important, no wider than 40 inches, and that's going to be outside of the tires, from outside to outside. It's not the width of the frame, so keep in mind you're going to you need some space between the wheels, and then you're going to have wheels and tires on there on each side, so that's got to be built into the width. Let's see. So keep those dimensions in mind when you start out, and it'll save you a lot of trouble. So if you see that first example there, that frame is too wide. It's the same width in the front as it is in the back, and that's not going to work. The tires will be sticking out way too far beyond 40 inches, and when you steer them, they're going to hit the sides of the frame. Here's a couple of examples of vehicles that are narrower in the front. You can see that you can turn the wheels pretty sharply. Now, these aren't ideal designs or anything, but at least they are examples, so you know that it can be done. So once you, with those ideas in mind, create a basic design. So just sketch it out, what you're thinking. And I would suggest you just take a pencil and a piece of paper and just kind of try to lay something out. A top view and a side view is good to kind of get a feel for what you're trying to do. Now remember, the idea of the frame can't just be flat. And you're going to have to think about the width, the length, the ability to put the axle underneath the frame in the back, a place for the person to sit, a place to support the steering and so forth, which we'll get to those details as we move through the process. Let's just think about the overall frame right now. Now, when you're designing this, it's nice to start with the overall picture of it, but you're going to have to take that and break it down into individual pieces, because we cannot bend the entire frame out of, just take one piece of tubing and put it into some kind of a machine and it'll make the whole frame. It's just not possible. So we'll break it down into individual pieces from your overall design. Think about individual pieces that you would need to make in order to build this frame. And here in our shop, we have a nice tubing bender, but it's just very difficult to accurately bend steel tubing when you have a whole bunch of bends on it. So I try to keep it to no more than 2 or 3 bends per piece, and then those pieces would be welded together to create the frame. So here's some examples of the tubing, individual pieces of tubing. So that's how we'll manufacture them. We'll cut and bend and notch the tubing as separate pieces, and then we'll assemble them together and weld them together. So that's the process we'll use to design it as well. So once you have your overall design, you want to start modeling the pieces. So start with the main kinds of pieces like the side frame rails, for example. I would create models of those, and eventually you'll want to notch them so that the tubes fit together and so forth. So for right now, just get the overall lengths and the angles and so forth. Now, I gave you the specification for the bends in the original packet of material about the go-kart. So you can't bend steel any tighter than a 3 or 3.5 inch bend radius, and that's a center line radius of the tubing. So don't try to have any bends that are sharper than that. 3.5 is really good for a lot of bends. 3 is as tight as you can get, and then we can go up to a 5-inch radius. So you can't have any giant sweeping radius on the bends. So here's some pieces of my frame. I've got the front bumper, side rail, the seat mount, and those parts modeled out. I'm not modeling the whole frame, I'm modeling the pieces of the frame. Then once you have those pieces, now clearly you can edit those pieces as you go along. You may decide that it's too long or too wide, or you want to change the angle. It's easy to go back and edit those pieces of the frame, so don't worry about that so much. And there are not that many pieces. Here's a sub-assembly of my frame. It's made of 5 different pieces, and you can see the different colors. Each color is a different piece of tubing. So you can see I limited each piece to being bent 2 times, and then when they're welded together, they'll be just as strong as if they were made out of one piece. So I mated them or constrained them, depending on your software, to look like that for my sub-assembly of the frame. So that's kind of the basic starting point for my frame. And then I added all the other pieces that I needed. I've got a place in the back for the motor. I've got that kind of light purple color. That's going to be the back of the seat, or kind of a sort of a roll bar or seat back. I've got a hoop to hold up the steering shaft, and a place for the person to see. And notice again, I do not have just a flat frame. And once you have that together, then you can put some drawings. So here I just put those frames on drawings. Here's some orthos, and here's an ISO with balloons and parts list, so you can see that's what we're going to have. When we get to capstone 2, you'll take the assemblies, you'll take the detailed drawings of the parts, and that's how we'll manufacture it. We'll build the separate pieces, and then we'll put them together to create the frame. So that's how the design will work as well.